Hey everyone, today we'll be studying about the strategy pattern. So this is one of the very important design patterns. So I would like to start by going through an example. So basically we are going to know why we are actually using this instead of just explaining the pattern. So let's say that you have a method. Let's just call this method a method only. And it does something based on some particular input. Let's call this IP. So it does something like if IP is this, then it returns something. Otherwise, else if IP is something else, it returns something else, and it's so on. So what happens here? Let's say in future we want to add another input type. Let's call this IP type X. So what would happen now is that to add this IP type X into this function, we have to change the logic of the function and add another else, right? So every time we are doing something to our system, we have to modify this function in order to have the functionality of the new thing that we are doing. So as we can see that this becomes a hassle in the long run for large scale systems. We would have to do this every single time we are doing something, and this also breaks the principle of one of the solid principle that code should be available for extension but not available for the modification. And this principle is rather broken every time we are doing another new operation. So how do we solve this problem for us? Well, we can take an example of a good uh, ride service, for example. So this ride service has different types of fees on the basis of the type of ride. So if the ride is on a surge ride, then it has some, let's just say that base amount times 1.5. And then there we can have a promotional ride, for example, some ride that is working because of a promotion, then the base times zero point 0.7, for example. And then we can have something like a seasonal ride. So due to some environmental season changes, for example, rain, it also modifies the ride. And then we have the normal ride, which is the base way. So if we try to implement a ride function that basically uh, gives us the price, what would we have to do? We have to check that if ride is search, then we have to return the base times 1.5, and so on we have to do until we can just return the base. So as you can see, this also breaks the solid principle because every time we are doing something new, we will have to modify this function. So how do we solve this for our ride? So we can start about thinking in a way so that we can separate the problematic component. So what is problematic for us? Our ride has a function that returns the base, the fare, and it has a component called as base. So this component is not problematic because it stays the same and affects the fares, but it has a pricing functionality that basically returns the fare on the basis of the type of the ride. So this type of ride also is a part of ride. But this pricing is completely separate algorithmic logic that is implemented into ride that is causing it to break the solid principle, and the class is then open for modification. So what we can do is we can separate this into two classes first of all. So let's just say that we have a ride here and this is a class, and then we have a pricing class. So this ride can use this pricing class and then get its price. But then again, if we look at it carefully, this also breaks up a principle that classes should implement a interface. So what do we do now? We can think of this thing as, since we can have different type of prices called a search price, and then we have this and that. So these are all different classes that can be broken down from pricing, and we can make pricing actually an interface for us. So if we look at it again now, what we can do is we can have our right, which would be a class. We can have our pricing, which would be an interface. And then finally, we can have different types of pricing according to the right type that would implement this interface, and they would all be classes. For example, search price, search price, uh, search price calculator, and similarly we could have different types of classes for different type of prices calculation. So this is a good separation of responsibility for us, and we have a thing going on where now no modification is required on the right part. If we want to add a new type of class, we just have to implement that class, and then we have to extend the pricing interface, and this would be a new type of pricing. So we can look at this via code and try to think about it. So let's create a project called as ride. So this is our main class. All right, let's clean this up. So first of all, we are going to implement an interface. We are going to make an interface called as pricing, or rather ride pricing. Let me just rename it because I made a mistake while naming it. So we can just rename it as ride pricing right here. So what does this do? This implements a function called as um, public int get ride pricing, and it takes in an input a ride, and that's all it does. Let's implement a ride class now. Okay, and now what we are going to do is we are going to extend the ride pricing. So we are gonna have search ride pricing, and this implements our interface that is ride pricing, and it will implement the function that int get ride pricing, and that would be taking the input ride, and then it is going to return the pricing, which would just be ride dot base price times zero point 0.7, for example, or something. So we are going to give a ride a final static int base price, which would be something around, let's just say, 178. And we can also use here, we can use doubles because this is how it would be. And let's just make this double as well. All right. This is one of the pricing that we have implemented for us. And now similarly, we could have another pricing. Let's just say promotional pricing, promotional, promotional ride pricing. And this class also implements the ride pricing. And now it would have its own function called get ride pricing. We can implement ride. and then it is going to return right dot base pricing times 0.3, something like that, right? Then we can have normal pricing, normal right pricing. This also implements the right pricing, and for us it would just be populate double get right pricing right right return right dot base. Yes. So this is how we can implement this, basically separating our logic. And then what we can do here now is different types of pricing that we have. Uh, this is being implemented for us. And then we are just going to use this with our main function when we create a right. And we can similarly create we can create a factory right pricing factory. This factory basically has a uh, public right pricing, and it basically what it does is uh, public right pricing equals no right pricing. We are just going to do is public um, I'm just going to see that it is going to return a right pricing factory, which will take in the input the string right pricing type, which is then if right pricing type is equals to search, we're just going to return pricing. Alright, and similarly, we are going to check. This is how we can calculate the right pricing type. And then we can also create an enum, right pricing type. And this enum is basically going to search, promotional, and normal for now. You can just take right pricing type dot search. What happened here? Then we are going to have our right pricing. Now we're just going to have our right that takes in the string same like it basically makes right pricing equals new pricing factory. We pass the right pricing. Right. This will return is the right pricing basically. Hmm. Yeah. Uh, yeah. Okay, and then we're just going to uh, make this as